All right, so I'd like to finish this section 23 on connectivity, and I'm going to have to keep these videos a little shorter. I'm having trouble uploading them. I think a lot of people are uploading videos these days. So anyway, this in what we're doing here is we're in this rest of this section. We're interested in the if you have two connected spaces, what about their cross product? What about the product of the two spaces? Is that connected in the product topology and whatnot? So let's start off with just taking the cross product of two spaces. And what if we take the cross product of two connected spaces? Is that connected? And it is, according to this theorem here. If you look at theorem 23.6 in the book, they actually prove this for arbitrary finite connected spaces. The cross product of any finite number of connected spaces is connected. So that's a pretty easy induction proof once you prove it for the cross product of two spaces. So let's prove this. The idea here for this proof is that we're going to want to use theorem 23.3, where which says that the union of a collection of connected spaces is connected as long as all the spaces contain at least one point in common. And so the idea will be to write X cross Y as a union of spaces that are connected that contain a point. Okay, so the key to doing that is to think of it this way, maybe visualize it. We're going to look at cross sections of these connected spaces. So let's envision the cross product kind of like this. And for what we're going to do is we're going to fix a particular value, A cross B, in X cross Y, right? So we're going to want this to be our point that's in common to all the connected spaces that we're going to create. We're going to create a whole bunch of connected spaces that contain this point right here. And so then the union of those spaces will be connected by that theorem 23.3. Okay, so what's the natural thing to do? Well, the idea is to look at a cross section. How can we get a connected subset of X cross Y? Well, what we do is we look at the set here, the space, X cross B, right? That's a subspace of X cross Y. It's the subspace of all the ordered pairs whose Y coordinate is fixed at B, right? So this is going to be a connected set because it's pretty much, we'll show in a minute, it's homeomorphic to X, right? X is connected. So the cross section of the set of all points with just a fixed Y coordinate is going to be connected. And so that's connected. Now what we're going to do is we're going to look at a cross section in this direction. Okay. Now this will just be some arbitrary point, not necessarily A, but it's an arbitrary point. And we look at the set of all ordered pairs where the first coordinate is fixed, sorry, not at X, but not at A, but at X, right? So X here, okay. So look at the set of all ordered pairs whose X coordinate is fixed for some value, right? So then what we're going to do is we're going to look at the union of these two spaces. I'm going to call that T sub X. T sub X is going to be the set X cross B union with X cross Y. Okay, so this is T sub X. Okay, the union of those two sets. So it would be this set here along with that set right there. Okay, and you take the union of those together. Now it's pretty clear that both of these sets here, this X cross Y now, okay, that's going to be the union for all X in here of the T sub X sets, right? If we take the union of all of these T sub X sets, basically all of these T sub X sets kind of have this line here in common, and what moves then is just this line. Imagine this line moving across, varying for X. You're going to get all the points in X cross Y. You could also do a set containment proof. I mean, any ordered pair X, Y, if you take the X coordinate, that point X cross Y will be in here. So it's pretty much it's clear that any ordered pair in X cross Y is in this union. So what we need to show is that a couple things. We need to show that each of these T sub X sets is connected. Okay, and then if they're connected, we just need to show that they have a point in common. But it's going to be pretty easy to show they have a point in common. The point A cross B is in this set, because A cross B is in this set right there. So A cross B is in T sub X for every X. So so it's gonna definitely be A cross B is definitely in the union. So all we really need, so let me point that out. So note that that A cross B is in T sub X for every X. Okay, so all we need to do now is show that T sub X is connected, and that's going to be pretty clear. So first, let's show that X cross B is connected. X cross B is connected because all you got to, and the way that we'll do this is we're going to use the previous theorem, the one we finished the last video with. The image of a connected set under a continuous function is connected. So let's define this function from X to X cross B, right, by f of X equals the ordered pair X cross B. Okay, so this is clearly going to be a continuous function. We could easily show that it's continuous, and so f is continuous. The inverse image, so f of X, is connected, but f of X is just, clearly this is an onto function, so this is just X cross B. That's connected. Okay, and in a similar way, you could show that the other set, that the X cross Y, is connected. Similarly, this set here, X cross Y, is connected. Okay, so define a similar function. So then their union, so T sub X is going to be connected because the union of two connected sets is connected when the sets have a point in common. Since so T sub X is connected since X cross B and X cross Y, these are both connected, and the element X cross B is in both of them. Okay, so that element being in both of those sets makes it connected. This is by theorem 23.3. So by theorem 23.3, the T sub X sets are connected, and then since A cross B is in T sub X for every X, and X cross Y is the union of all those, X cross Y is connected. Whoa, what happened? Oh, there it is. Okay. Okay, so by theorem 3.23 then, or 23.3, X cross Y is connected. So hopefully that makes sense to you there. I'm gonna pause the video here. I'm gonna stop the video, and I'm gonna show two examples on the next video to finish up this section, again, because I want to keep my videos shorter.